Okay, so today we're going to tutorial 7 and 8, right? So let's start the tutorial sessions today with tutorial 7. Can you see the screen? The tutorial 7. So we'll start our sessions today, and let's record the sessions. Number 1, they ask what you need for the I/O device to become a modem. To become an I/O device, you need the network interface card in your PC so they can communicate with your processor. Okay. Then the next questions, they ask about the factors which affect the performance of an I/O of a system. So there's two. One is the technique you use. There's few more, but the most important we want to discuss in this chapter is these two only: the I/O techniques and also the bus system. Okay, how you communicate with the I/O, the technique you use. Then also the connections, the bus system, how you connect your I/O to your processor, how many bus you have, and how many devices connected to the same bus, and these two is the main factors which will affect your I/O performance. Number 3 is they ask you to explain briefly the I/O techniques. So how many I/O techniques we have learned in this chapter? Anyone? How many techniques we learn? We learned 3, right? So what are the 3 techniques? Should be the these 3, right? Program, interrupts, and also DMA. Okay, and we also discussed a bit about DCA, right? Direct cache access. Okay, so the main 3 we learned is program I/O, interrupt I/O, and also direct memory access. Anyone have any questions on this 3? Oh, okay. This 3, how it works. So we go to number 4. They ask about the difference between memory map I/O and also isolated I/O. The main difference is they are not sharing the memory locations. Okay. For memory map, your I/O device is sharing the memory locations with your RAM, okay, with your computer internal memory. Then for isolated I/O, they are not sharing the memory locations with your processor's internal memory, okay? Let me know if you have any questions on any if you have any questions. Okay. If not, I will just go through quickly. When a device interrupt occurs, how your processor is going to know which device issue the interrupts. We have learned how many techniques in this chapter for the processor to know which device issue the interrupt. 4, right? So the 4 should be the first one is using multiple line. You have how many devices want to give interrupts, then you need to have how many lines you connected to all the device. The second one, you have only a few lines, then you're using software to send signals to ask all of the device connected to the same line, then they respond if they are the one who are sending out the interrupt signals through the software program signals. Okay. The third one is called daisy chains. They're using connections to the first device connect to your processor, then the subsequent is connect to the previous device. So they call it as a daisy chain. They will pass the signals at everyone connect to the same interrupt lines. Okay, then the processor will pass the signal, acknowledge signals to the first device. Then the first device will pass the signal to the second if they are not the one who send the interrupt signals. The last one is a bus arbitration. So whenever you want to send an interrupt, you must own the bus, then only you can send out the interrupt signal. Then we come to last questions. When a DMA module takes control of a bus and while it retains control of the bus, what does the processor do? The processor cannot do anything. It can only process the data inside processor. So they cannot use a bus. Okay? So they have to wait for the DMA to finish using the bus, then only they can go in. Because you have only one system bus. So at the same time, you cannot use the bus for both device, DMA and processor. So your processor to pause for the cycle whenever your DMA is using the system bus. So that's all for tutorial 7. Any other questions? If you have no questions on tutorial 7, then we go to the 8, okay? We go to tutorial 8. Yes, the last question in tutorial 7. Any problem? it shouldn't be the same as interrupt breakpoints, because if it interrupts, then the processor is still working if it's interrupt breakpoints. Just the program running is different, right? But if it's a DMA process happens, the processor is running also, but the processor is remain on the same program. The only things they cannot do is they cannot access to the memory only. They still can execute, they still can decode the same program inside your microprocessor. So let's say this is your processor, microprocessor. This is your system bus. This is your memory. Then this is the I/O device or the DMA device. Okay. So for DMA, let's say you are running a program here. This is your program A. Okay. Then the sequence of program execution. The sequence of program execution is they will execute line by line, right? They will transfer the first line from the memory, first line of instructions from memory to your processor IR register, right? Then they decode, then they execute inside. Okay, so let's say up to certain points, there is a program asks the DMA to transfer some data, right? They do the same. They will transfer the instructions to your microprocessor. Then after the microprocessor decoded and they knows you want to ask the DMA to do the works, then they will send the command to DMA, ask them to do the works. Okay, after that, they can continue to getting data from your program A. Okay, they continue run the program A. They are doing the same thing. They are running the program A. They continue to do the program A. But when your DMA is starting to transfer the data, so let's say they are getting something from your I/O device, anything, or maybe your network. Okay, you want to transfer something to memory, they transfer to DMA. Then at some point, when you fetch one instruction come to IR, you are doing decode. Your DMA can start to use the bus because you're not fetching anything yet. So the DMA will go and send things to your memory. So at this moment, when your DMA using the bus, there's no connection, there's no transfer of data between your memory and microprocessor. But your processor is still running inside. They still can work inside your microprocessor. The only thing is they cannot use this bus because the DMA is using the bus to transfer data to your memory, right? And your microprocessor, basically, they are still working on the same program A. Okay. For interrupt, is a different things. Interrupt, your microprocessor is here. Then you have a memory. Then you're running a program A. So let's say you still connect to your I/O devices. So let's say this is a DMA also. So you're running program A. When, let's say the DMA has done the transfer, okay? Then they will interrupt your microprocessor. They send the interrupt signals. Then your microprocessor may need to stop and go and do some, maybe they need to do another program B after the DMA has done the transfer. Okay, so your DMA giving interrupts to your processor, then your processor will stop running program A. they will go to running program B. After finish, they need to come back to your program A. Okay, so in the interrupts, your microprocessor still using the system bus, right? The difference is they move from one program to the other program. But in the DMA data transferring, they are running the same program. Just they will stop using the bus when your DMA want to use a bus to transfer data. Clear? I hope this explain what you your question. Is it the explanation to your questions, or you have any other questions? No, no questions, If no questions, then I will move to tutorial 8. So we continue with the tutorial 8. So they are asking the elements in your machine instructions. So what are the things we should have in the machine instructions? Wait, I'm answering the questions for this one. The slide is saying that your processor, so it depends on which one you want to use the bus. It's either only one device can use the bus at one time. So if you want to let your processor to use the bus, then that means your DMA need to stop. And the question is tutorial asking is that if let's say now you want to let your DMA do the transfer and take control of the bus, then your processor has to do what? So means your processor will stop using the bus whenever each cycle is using by the DMA. Right, so in both way also can, either your DMA using the bus or your processor using the bus. But the important point is at one time only one device can use the bus. It's either your DMA or your processor. But since in your tutorial questions they are asking if your DMA is to take control of the bus, what you have to do, your processor. Okay, so the processor can do is only wait for the DMA to finish using the bus. Okay. Any other questions? If no, we come back to tutorial 8. So they're asking, number one, they're asking the elements inside the machine instructions. So what are the things you should have in your machine instructions? The most important thing you should have in your machine instruction is what? What are the things you should have? Minimally, you should have what inside your instructions? Anyone have the answers? What is your machine instructions? Any example of machine instructions? When we talk about machine instructions, it mean what? Yeah, they should have an opcode source, memory, destination, and yes, right. So I just received the message now. So is it related to opcode, source, result, and next instruction? This is the 4 things you should have. The most important, minimally, you should have the operation code, right? At least you must have the opcode. Okay, so this is the 4 things you can have inside your machine instructions: the opcode, source, and destination operand. Okay, then the next instruction reference. So when we need to use the next instruction reference, what types of machine instruction we need to have the next instructions operands reference? Yeah, for example, your jump, your branch, you need to have the next instruction reference. You need to tell them they need to jump to which locations. So in that instruction, you need to have the next instruction reference, the address of the next instructions. Okay. So for the add, it's just having the opcode, source, and destination, right? You add something from the destination and put them into the source. Number 2. So where is the locations to host your source and destination operand? You can put in your register and also your memory, the one you learn in the labs. You can put in the EAX, then you can put into variables you define, and the variable should be inside of memory locations, right? Registers or memory. Number 3. So let's say you have instructions with a for address. The address will be used for 2 operands, then one is for results, then the next one is for the next instructions. Okay, this is example only. If they're asking if in your instructions contain for address. So what are the for address can be used for? 2 of them can be used to point to the operands, the location where you store the operands. Then one of the address is point to the destinations where you want to store the results. After that, then the last address is used to point to the next instructions. What are the 5 important instruction set design issues? So this is the one in the slide. There's 5. The operations, which is the opcode. how many types of operation you want to have in your instruction set. Then your instruction set want to works on the how many types of data. Then the instruction format, how many bits you want to have in your instructions, whether it's 32 bits or 64 bits. Then the number of addresses you should have in your instructions. Okay. So you need to decide what are the instruction format. Then followed by registers. How many registers you should have in your, how many bits you should allocate in your instructions to point to all the registers. The last one is the addressing, right? The addressing mode. What kind of addressing mode you should have? Okay, any question on this one? No, we go to the next one, number 5. What is the difference between arithmetic shift and logical shift? So for logical, it's just normal shift. You shift in 0. Okay. Okay. For every bit you shift out, you replace with a 0 in the other side. Right. If you shift left, then you replace 0 in the right. If you shift right, you will replace 0 in the left, right? You move in 0, then you shift out the bit. For arithmetic, you will return the sign bit, okay? The sign bit will not change. Any questions on this logical and arithmetic shift? For your the lab questions, the lab sessions, Yeah, call can be considered as a transfer of control also. What else? What else example you have in the transfer of control? You need to execute again, right? So it's mean a loop, right? Okay, so if you are in the loop, you need to repeat the loops. Then for decision making, after you compare, then you need to jump. If less than or greater than, then you need to breaking the task you want to return. Okay, the return also is a transfer control. After you call the procedures, then you done, you read back to your main program. Okay, so this is the time when you need the transfer control instructions. Okay. Then number 7. They list all the instructions to perform the x equals to that formulas. Then they give you three types of machines. One is using one address only, the other 2 and 3 address. Then they ask you to do the program for 1, 2, and 3 address. So this should be your answers. Okay. Is this the one same as the lecture slide? I think there's one example in the lecture slide also. If the question didn't ask to minimize, then no need. Yeah, you just need to complete the program to get the X. Okay. Don't need to minimize the number of register used. But as a programmer, you should minimize the number of register used. So this one is the same as in the slide, is it? So any question on this one? I think maybe we start with the one address, okay? So in one address, they are using, let's say only one address means they are using accumulator, okay? Whenever you do a load, you're loading into your accumulator. How many operand? I think the address means the operands. How many operand you can have inside your instructions. One address means there's only one operand inside. 2 address means 2 operands. 3 address means you can have 3 operands inside. think the question should ask in this way. 1 means 1 operands, 2 means 2 operands, 3 means 3 operands. Okay, there should be the same. Okay, so for the one address, if you load E means you're using the accumulator. So this line means this line means AC equals to E, right? Then the second one you multiply with F means you multiply F to your AC. Right? So at the end your AC equals to E times F, right? Then you store into T, means you store the content in AC into T. T equals to AC, which is equal to E times F. Then you load the D into your AC again. So then before you load, your AC should equal to this one. After you load, your AC is replaced with the data D. Then they subtract with the T. So means AC minus T equals to D minus E times F. Okay. Then they store your T. Store into T, so this your T will equals to D minus E times F. Okay, then followed by load B. So your AC equals to B, right? Then the next one is multiplied by C. Then the add with the A. Okay. Then they divide with T. So now this is your T. So means your AC will equals to X, right? The one in here. Then they store it back to X locations. Okay, so means they store it back in the memory. Then for two operands, it will be more easier to do it if two operand. So means you move these two operand. Move R0, you will get R0 equals to E. Then you multiply R0 with F. R0 equals to E times F. R1 equals to D. Then subtract R1, R0. So your R1 equals to D minus F. Then you move your B into R0. Then just divide. So you get your R0 should equals to X. Okay? Then you just move R0 to store it in the X. So last one will be more faster. You just multiply. So at the end, your R0 equals to E times F. Then they subtract D minus E times F. So your R1 equals to B times C, then your R1 equals to A plus B times C. After divide, so mean you're using R X over Z. This one they're using R1 over R0. So equals to the formula here. Okay, so any questions on this one? We must do the questions ask you to do answer all the three, right? A, B, C, 1, 2, and 3 addresses. So you must have these three answers. Yeah, AC is one register inside your processor. Yeah, you can do either way. A plus B times C first or B minus E times F first also can. As long as you get the end result, X equals to that equations. Okay. If you have a processor, you go to look into their instruction set architectures, they should have this kind of thing in the data sheet. Okay, they should have this kind of thing inside your. They should have this thing inside your microprocessor, the data sheet, to tell you how the operations of the instructions. Okay. So all these things should have inside your data sheet. Then only you can know how is the instructions works. If you go and check your labs one also, they should have online. You can just simply check. Yeah, I was thinking the divide also. Is it? I think there's some mistake there in the slide, in the questions. So how should we do the divide? Divide should be what? Divide x R0 R1. So we should invert this one, divide R1 R0. Is it? Anyone can help to check? So this one should be R1 R0. Because in here they didn't give the correct one, I think. There should be Y and Z, right? This is your, let's say this is your X, this should be your Y and Z. They should give Y and Z here, right? For three operands. X is the first one, destination. Right, so this should be, I think this should be in this form. Yeah, so this should be R1 divide R0. This one should be correct for the DIV. Right, you're right. Should be X, R1, R0. Any other questions? If no questions, then I think that's all for today. We still have one question, right? Wait. We have the last question, is it? Yeah, this is your last question. Logical right shift, 4 bits. So the logical shift right 4 bits, you should get. Right, then logical left shift is a arithmetic right shift. Arithmetic shift, 4 bits also. Then arithmetic left shift, let's say we return the shift bit. Return or not, you will get the same answer. Right rotate 4 bits. Left rotate. Is it correct? Yeah, so they just store in the X locations. But in the questions, they didn't tell you you should store in X also. But if in exam you didn't store in X, should be okay also. Yeah, but if you need to store in X, then you should put X, so you can straight away store into X instead of put in T. Then you need to move to X again. Right, what explained in the bottom is correct. So since they want to store the final answer in the X locations, so instead of putting them into T, you can straight away put them into X. Okay. Any other questions? Final should be 4 hours. Yeah, because we want to give you more times to do on it. You should be happy, right? It's 4 hours. So I stop recording first. Yeah, there's an open book, so it should be more difficult. The chapter we cover will post in Spectrum after next week. Okay. Yeah, lab questions were considered in your continuous assessment. There's 20 marks, right, in your lab. It's open book, so it should be easy, right? You can refer to your books, your notes, even online. Yes, next week we'll have a tutorial sessions. Should be the last tutorial sessions. The midterm will, the continuous assessment mark will give you after week 14, right? We still need to compile everything, calculate every total marks, then we'll give you the earliest in the week 15, okay? Lab questions, any random number? Which lab questions? The lab test 2. The key in the number A, B, C, D, is it? Yeah, you can any random number. You can key in any random number, and please don't too complicated the questions. There's one student asked me whether we should detect if it's not a number key in. So we just assume you key in a number. You don't go and key in others string. Okay, you don't need to have the program to detect whether it's a string or it's a number. Okay, so just assume the user is keying a number. Okay, then you check for the score A, B, C, D, and only. The submissions in a .asm file is better. Okay, don't put them in the Word. You put in .asm. If you want to compile, then we can straight away copy in and compile. Yeah, you submit in the zip files with content all the your submissions. ASM file, output pictures, yes, can. Report means what? Report means in the Word format. If you have submitted, then it's okay, just leave it. Okay? If you haven't submit, PDF. If you have submitted, it's okay. If you haven't submit, better put in ASM files and also zip in the folder. If you want to run the code, then you can copy the code. The answer should be the one in the screen now. Should be a div x r1 r0, this one. Okay? Yeah, you zip it in the file, in the folder, yes. You submit a zip folder. Picture any format as long as I can open and view. And one information, final is an open book, but it's not for you to discuss. No discussion is allowed. We found some answers in the midterm is exactly the same. So mark will be deducted for both students. If we found there's exactly the same answer inside and just yeah. Okay, so no discussions. You can check anything, open book, just no discussion between students. Any other questions? If no, then we'll end today's sessions. Okay, so that's all for today. Thanks.